All right, let's look at another example of drawing Lewis structure. This is remember called ammonia. And so let's do our little S equals N minus A rule business before we get started with the skeletal structure. So available, that's, how many electrons are available from all of the valence shells of all of the atoms that are in the molecule. In this case, I have nitrogen. I have one nitrogen, and I have hydrogen, and there's 3 of them. And you have to look at the periodic table to remember that there's 5 valence electrons in nitrogen and 1 valence electron, because it's in group 1, for hydrogen. So nitrogen has 5 valence electrons, and hydrogen has 1 valence electron. So my total number of available is just going to be 5 plus 3 is 8 available electrons. That's my available. And then needed, in this case, of course, we've got 1 nitrogen, 3 hydrogens. Nitrogen is, like most other elements, it needs 8 to satisfy its valence shell. And hydrogen is unusual. It only needs 2. You have to remember that. And so 8 plus 3 times 2 is 6. The total needed to satisfy individually each atom here is 14. So to predict the number of bonds, S equals 14 minus 8 equals 6. That's the shared electrons, individual electrons. But to figure the number of bonds, since there's 2 electrons per bond, it's going to be 6 divided by 2, which is 3. So in this particular case, I'm predicting 3 bonds. All right, so draw your skeletal structure, connect each atom. Now, this time again, because I have a clue and I know that hydrogens have to be terminal, and typically the central atom is listed first from those first few instructions on our rules, I knew not to string it go NH. I knew not to do that. I knew not to do this, because that's not what hydrogen does, okay? It's terminal. It can only have 2. And so I can see when I put this thing together, remember each dash is a pair of electrons. I've used 2, 4, 6 of my 8 available electrons. And according to the rules, once you've made your skeletal structure, go back and see if you have any electrons available. If you have electrons available, place them on the terminal atoms first to satisfy the octets. The terminal are the ones on the outside. The central is the one in the middle. But I can't put them on the terminal atoms because hydrogen can't have any non-bonding pairs of electrons. All it can do is form 1 bond, because that satisfies its 2. And so then it says, if all the terminal atoms are satisfied, then go to the central atom and place your remaining electrons. And since I had 2 left, I placed them on the central atom, that is nitrogen. So you can double check, nitrogen has 8 and each hydrogen has 2. Okay, so that's how we decide what's connected to what and what types of bonds. Is it a double bond or is it a single bond? Are there non-bonding pairs of electrons present or not? You use the Lewis structures, okay? You use the rules for the Lewis structures.